All right, guys.
The pants.
Let's get focused. All right.
You can make fun of my hair.
We are in our notes, section 2 and 3, and hopefully we're working on finishing that. So, directions to 7B. Find a cubic function. We talked about this. Find a cubic function the other day. We don't have enough information to find a specific cubic function, but we can build possibilities. And so our roots are 1, 1 plus root 2, and 1 minus root 2. These are the zeros of a polynomial. In other words, if you graph this, these would be the intercepts, right? 1, 1 plus root 2, and 1 minus root 2. Those would be the intercepts. Which means if 1 is a root, isn't x minus 1 a factor? And if that is a root, then x minus 1 minus root 2 is a factor. Remember, if that's a root, it's like x equals that. Well, it says that, x equals that. And then I'm going to subtract over to get my factor. So it's x minus 1 minus root 2. And then what would this one be? X minus 1 plus root 2. Now, all that has to be FOILed together. Do whatever you want, but I would suggest you FOIL these two first because they are conjugates of each other. And what happens every time you multiply conjugates? Remember doing it with the i's? Don't things cancel out? So if you try to multiply these two, you're going to have a mess. It's fine, it'll work. But these two, it's going to work out nicely. So I'm going to go ahead and multiply my two conjugates together. All right, so first times first. Outside, or first, I better go in order, this is going to get confusing. So I'm going to do x times x, I'm going to do x times negative 1, and x times negative root 2. So I did my x's, x times boom, boom, boom. Now I'll do negative 1 times boom, boom, boom. And then I'll do root 2 times boom, boom, boom. Remember, when you multiply a root 2 times a root 2, they cancel and leave you just with 2. With any luck, everything with a radical is going to cancel. So does this cancel? Yep. Does this cancel? Yep. So all I have left is x squared minus 2x minus 1. But I'm not done because I have to multiply that now times the other factor, which was x minus 1. So I'll do the same thing. X cubed minus x squared minus 2x squared plus 2x minus x plus 1. With any luck, I added right and multiplied right. Somebody confirm if you did it yourself.
What is your iPad on?
I think I turned it on.
It's on. Yep.
Thank you for keeping track of me. I appreciate that. Okay. Everybody all right with that? Now, remember, that is kind of the general cubic polynomial that has these as roots. We could, if we had more information, this is all we have, so this is the best that we can do. had more information, then we might have a coefficient out here in front of this. So like a 2 out here in front of all these factors, and that would make my hills and valleys taller. Or it might be a -2, in which case it would be flipped upside down. I have no idea. This is the best that I can do, given what I know. That's it. Now, look at question 8. What's different about question 8? What does it say? Find the cubic function with zeros at -2, 1, and 4, and containing the point -1, 6. Now that right there narrows it down for me, because there's only one function now that's going to contain, I don't know that that's a maximum, but it contains that point. There's only one of those. There's only one. So I'm gonna start out the same way I did. I'm gonna build my factors, just like I did here. One of these are easier. What are the factors if these are the zeros? X plus 2, minus 1, minus 4. Would you agree with that? Now, before I multiply that out, you'll have to decide which way is easier for you. Before I multiply it out, I'm going to stop and think about, there is a coefficient in this problem that makes it sure that I go through that particular point. So before I FOIL it all out, and this is what you'll have to decide if this is easier or harder for you, I'm going to go ahead and plug in 6 for y and -1 for x. 6 for y and -1 for x. Do you see how doing that is going to allow me to find my a coefficient? It's easier for me to do that plugging now, because if I multiply it out and then plug, it's fine, but I'm going to have to cube numbers and square numbers and whatever, and I don't like to do that, so I like to plug it in now. So I'm going to have 1, -2, and -5. So that's what, 10a? So it looks like my coefficient, if I multiplied and added right, I got 3/5, 6/10. Did you get 3/5 or 6/10? So my polynomial is 3/5 x plus 2, x minus 1, x minus 4. Sometimes I don't make you multiply it out, and I want to save time, so we're not going to multiply this out. If you had to multiply it out, you would do all this FOILing, right? And then take each one times 3/5.
Will you be okay if I say something like
Well, sometimes I am. So this time I am. Yes, it'll say multiply out or not multiply out. So yeah, that's good. So do you see the difference between the two problems that we've done so far today? What allowed me to actually find the one answer to this problem? The fact that I had a random point on the curve, because there's only one that's going to go through that random point. Okay? Perfect. Now, let's do a quadratic regression on our calculator. We know what that means. We're going to go to Stat Edit. And what are we going to put in here? For Stat Edit, we're going to put our x's in. Stat Edit, what's L1 L1 is your X's, L2 is your Y's, just like a T-chart. And then you're gonna go to, I cannot talk and do this. We're gonna go to stat, calc, and choose quartic regression. Everybody find it? Now remember, the calculator does not give you the equation ever. You have to build it yourself. So y equals a, which for me is negative 0.017, I'll just round off to the 1,000, x to the fourth, plus 0.226 x cubed, plus 0.289 x squared, minus 3.202 x, minus 21. Are those numbers remotely correct?
Yeah.
Okay.
Is the C value always going to be cubed? Because it's just going in order.
It goes in order. It tells you that, Lucy, if you look at, I gotta start all over again. It gives you, when you hit quartic regression, it gives you, it says AX to the fourth.
Yeah, it just, mine doesn't have the C. It just goes, well, like it has C value, but the equation doesn't actually say C. It just says like dot, dot, dot.
Yeah, mine does that.
They're assuming you can figure out the pattern that's there.
Oh, that's what mine says.
Well, that's telling you.
Oh, okay.
Okay. That's easy. All right, here comes the first exciting problem of the day. That was pretty easy. One quick comment about this. How many points did I give you? 5. When you do a regression, you have to have at least one more point than the degree of the regression that you're doing. So if we're going to do a quartic regression, we have to have at least 5 points. If we were doing a cubic regression, we would have to have at least 4 points. Now, we could do a cubic regression on this because we have at least 4 points. It's 4 or more. And that goes back to something you already know. How many points does it take to make a line? 2. What's the degree of a line? 1. It always takes at least one more point than the regression you're doing. Okay? All right. Now, let's look at number 10. This function, we're going to put our thinking caps on here. This function is the volume of the box. After you cut the corners out, you know, like we do. Only we never multiplied it out. We always use an equation that looks something like this. 10 minus 2x, 7 minus 2x times x. Remember that? And from that equation, we knew the dimensions of the paper we started with. This paper must have been 10 by 7. And from those dimensions, this paper's 10 by 7, we knew that x had to be between what for this problem? 0 and 3.5. Smallest dimension, half the smallest dimension. Now, they took an equation just like this. Look, if you FOILed this out, wouldn't these two give you a positive 4x squared? And then when you times it by x, wouldn't you get a positive 4x cubed? So somebody has done that and come up with this. They took something that looked just like this, only they did all the multiplication and came out with this. The question is, what's the domain? We want to know what values are possible for x. What's the domain? So he's got a thought. There are a couple strategies I can think of off the top of my head. Can you think of a strategy? Factor it, you mean? Okay, so Allison says, okay, if I had these, it would be an easy problem. So she said, what if we take out the x, that's this x right here, take that out, and then look at this, what's left, and understand that that is going to be something minus 2x, something minus 2x. That's what it has to be, if this is the way we're going.
Oh, it's just flipped. It's confusing. What if,
Well,
wait, why didn't we take out a 4x?
because we're trying to build these factors, or at least I think that's what you were doing, isn't it? Now, you could take out a 4x and then put the 2's back after you got it factored. That would work. So if you're more comfortable with that, you can take out a 4x, and then what would our numbers be? 266 divided by 4. Oh, it's a fraction. All right. So,
Oh, factors.
Allison, you got any thoughts on that? Do you understand what she's doing though? She's got a really good thought. She said, if I could come up with these two numbers, then I would know what the limit on my x was. Because I'm making these up totally, but let's say this one was 66 and this one was 70. Then we would know that x had to be less than 33, half the smaller dimension. But the issue here is going to be coming up with those numbers. Could we do it? Yes, we could. What else might we do if we don't really want to mess around trial and error, which is what it would be, trial and error, guessing those numbers? What else could we do? Could we do this on our calculator?
Yeah, but we don't have to do anything.
Could we graph it on our calculator?
Yeah.
Now, when we graph it on our calculator, I want you to think about when you're actually doing this problem to come up with the maximum. You only graph like this part of it, right? That's a cube. It's going to keep going. There's going to be more to the picture. But we only ever want this piece, right? Because this piece is the x's that count in the problem. So what if I put in this equation into my calculator and hit graph? Now, maybe before I hit graph, I should adjust something.
Window.
So I don't want x or y to be negative. So my minimums should be 0. I have no idea what my maximums are, but I'll just make something up. 500 for which one? For x? Whew, that's pretty big, but okay.
Or like, well, no, sorry, 200.
So you're gonna let x be 200?
Well, because something times something is gonna equal like 2,000.
I get 1,000 on my one.
I mean, I know the volume is now at 2,000.
Need your X to be that large.
Yeah, your X isn't gonna end up being that big. Y will need to be big.
Yeah.
But X, let's pick something like 50 for X, okay? Let's pick 50 for X and maybe 5,000 for Y. And hit graph. Now, if you put 50 in for X and 5,000 for Y, I think the X is too big because this is all I want to see. And the Y is too small because I don't see the top of that hill. I am seeing more of the graph than I want to see. So I'm going to change my X max, my X max to 25 and my Y max to 8,000 and hit graph.
Wait, what did you set your X max as?
25 and 8,000. Now, am I closer? So I'm gonna change my Y max to 10,000. Barely, but it's good. So now, what I see on my calculator is exactly what I wanted to see. I see here to here to here. You guys, come on. There's your equation. Y equals, type it in. Your X max, your X min is 0, your X max is 25, your Y min is 0, your Y max is 10,000. Now, you are all smarter than I am. All I did was play around with it. There's nothing magic that I did. I just had the self-discipline to just play with it for a minute till I saw this picture. Why did I want to see that picture? Because every time I've done a box problem, that's the picture I've wanted to see, right? This one's no different. I'm just looking for different information. What part of this graph do I need to figure out now on my calculator? I have the graph. I need the zeros. Now, I know this one's 0 because it's got a factor of X, so I know that one's 0. I knew that from the beginning. Isn't my minimum X always 0? This is the one I need to find. So second calc 0, left bound, right bound. It goes off the screen, that's fine. Then put it in between. And that one is 21.5. Remember when we had that thought about dividing out of 4 and you got fractions and decimals? That's because they're part of this problem. So if that dimension, if that right there is 21.5, that is an X value, isn't it? So that is the biggest X can be. Because if you go bigger than that, now you're going to be down here and your volume will be negative, which is impossible. So these are the X's that we need. We always knew 0 would be the minimum. Now we know the maximum is 21.5. Okay? All right, well, that was a rockin' good time. Let's see what's next. Oh, that was 2.3. Oh, good. That homework will be due on Tuesday. All right. On to 2.4. This is where the rubber hits the road. Because the other day, yesterday maybe, or whatever day that was, we graphed polynomials, and it was so easy. You were doing it in the snap of a finger. because our polynomials all looked like this. Right? And when they look like that, we know enough about polynomial and behavior. We just graphed it. So we put intercepts at -1, this is review, 2, and -3. And then remember what we did? We counted up the x's. How many do we have? 4. I don't know, he said 5. There's 4. There are 4 x's. Now, 4 is an even number. So whatever's going on in this picture, it starts up and ends up. That's what they do when they're even degree. Except, we put a negative out in front of it. So instead of up, up, it's gonna be down, down. So it starts down here, it comes up to this point. Now I have to decide what to do when I hit that point, which came from this factor. Just goes right through. Goes for a while, turns around, comes down. When it hits that one, it also goes through. Goes for a while, turns around, comes back. But that one bounces off, and there we are, down, down, just like we knew it would be. Okay, that's so easy. It looks hard, but it's incredibly easy. What made it so easy is we knew exactly where to put the dots, right? And we knew what the powers were on those parentheses. What?
How do you know which ones bounce off?
It's a squared factor, it bounces off. Okay? All right. What is different? This is a cubic polynomial. What is different about it though?
It's not like broken.
It's not factored. And we're doing this without a calculator. So we're not going to be typing it in and doing second calc 0. We are having to find the factors of this thing on our own. We did one of these the other day, but the difference was it factored by grouping. That's not looking very promising for this problem. I'm not sure you're going to be able to group this. Do you remember from last year? By the way, Mr. Miller was here today subbing. Do any of you remember what he told you about this? Maybe he didn't, I don't know. Am I going to teach you something brand new? How exciting is that? All right, so here's the deal. Remember that the factors are numbers that give you, if you plug in, or the factors come from the zeros. And the zeros are numbers that if you plug them in, you get 0. So if you put -3 into this equation, it equals 0. That's what it means to be a 0. So if I could find a number to plug in here and get 0, then I would have one of my dots, right? So I could start guessing, and I'm really logically trying to figure out, I could start guessing numbers. That could be a very time-consuming process. I could get lucky right away. So I'm going to give you some hints about that. But ultimately, guys, if you're doing it by hand, that's what you're going to do. You're going to guess numbers, plug them in, and see if you get 0. Now, I want to narrow down your options, okay? I mean, this problem, this is our first example, it's kind of rigged, there's a real easy choice right off the bat, but I want to show you what to do when you don't have any obvious numbers. The possible rational roots, and those algebra teachers usually say P over Q. Anybody, that sound familiar? Does that sound familiar? Possible rational roots. These are your possible guesses. When you say, oh my gosh, I gotta find a number that will make that thing 0. The possibilities are factors of the constant, and by constant, that's this guy, no variable, over factors of the leading coefficient, which for us happens to be 1. That's really good news. 1 is a nice number to have. So you did do it last year. Bummer. So what are the factors of 110? Plus or minus? What?
1 and 110.
1 and 110.
2 and 55.
2 and 55.
5 and 22.
5 and 22. 10 and 11. Did I get them all? Factors of 110. So when you start guessing numbers, that is the pile that you're going to guess from. Now, you might be thinking, this is 4, that's still a lot. Not compared to infinity. This is a little pile compared to all the possibilities in the world, right? Something else. See how these are both negative? That's pretty big. So I might start with a negative number, because a negative number will make this positive and somewhat cancel this one out a little bit, or at least tone it down. So what if we started with negative 1? What if we plugged in negative 1? Well, we get negative 1 plus 2 plus 109 minus 110. What does that add up to? 0. There you go. So you found one right off the bat. Kind of an obvious choice. It might not be your first choice. You might try negative 11 or something. I don't know. Doesn't matter. Pick a number and you keep guessing until you get one that equals 0. Now, you could keep guessing, but there are a couple hazards with that. One is it takes a long time, and 2 is if there are multiple roots, that is if you have a factor squared, you'll never find it by guessing. So my suggestion is, the minute you find one that works, divide it out. Just like if I gave you a big number, like 300 or 3,625, and I said break this down. Well, you look at that number, probably most of you would say, well, I know 5 goes into it, so you're going to divide the 5 out. Well, you know negative 1 goes into this, so we're going to divide it out. And we're going to divide it with synthetic division. So out here in the box, or the bird cage, or whatever you people call this, I'm going to put a negative 1. I'm going to put the exact number that was a factor. Negative 1 gave me a 0, so I'm going to divide out negative 1. Here are the coefficients in the problem. Does this look familiar? Synthetic division. All my coefficients straight out of the problem, right here, straight out of the problem, all my coefficients. Bring this 1 straight down, this guy right here, whatever he is, he's a 1 this time. Bring him straight down. Multiply, add. Multiply, add. Multiply, add. And we knew that would happen because we found a factor. And when you divide a factor into something, the remainder is 0. If that doesn't happen, you have messed up somewhere. That should always happen if you have a 0, if you have found a root. Now, what's left after the division? Well, remember the original was x cubed. but I've now divided it, so the power goes down by 1. So I have x squared plus x minus 110. Now that's a quadratic. I am not guessing with a quadratic. I am either going to factor it or I'm going to use the quadratic formula, because my job now is to find the zeros of this quadratic. I don't want to go through all that with this. So that actually factors quite nicely, plus 11 minus 10, which tells me that where are my other two zeros? At negative 11 and 10. So here's the negative 1 I found, here's the negative 11, and the 10 that I just figured out from the factors. Now, here are two of the factors. The other one would be x plus 1, if you wanted to write it down. That's the negative 1 you found. So here are your factors. Are any of them like squared or anything? Nope. Which means when you draw this picture, you're just going to go woo, 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 right? Now, where are we starting? Well, look back at your problem. See this coefficient right here? He's positive. So where does a cube, or any odd power, start if it's got a positive coefficient? Down at the bottom. So it's going to start down here, zip right through, and zip right through. There you go. There is a lot to that problem. I'm glad you've done it before, because it's a lot to digest. If you can't factor by grouping, then you're just going to have to start guessing until you get something that gives you equals 0. Okay? All right, let's try the next one. I think the next one is the same scenario. By the way, guys, if they factor by grouping, factor them by grouping. That's always faster. And if it doesn't factor by grouping, then we're going to have to guess. I don't think this one groups, do you? Now, when we say it doesn't factor by grouping, we're not saying I can't factor anything out. Because certainly I could factor something out of these, and I could factor something out of these, but the problem would be the parentheses that I'm left with would not be the same. Okay, so what are my PRRs, my possible rational roots? Factors of 96, plus or minus, yep, factors of 96, over, again, 1. Now, I'm not going to write them all out because there's a bunch, but I'm going to think in my head, it's got to be a factor of 96. So I'm not picking 5, right? Not picking anything weird like that. I'm just going to pick something. So what do you think? I don't think 1's going to work this time. The numbers don't look like 1 will work. How about 2 though? 2 looks promising. 2 would give me 8 minus 16 minus 88 plus 96. You think that works? So I'm thinking in my head, I gotta have a number that I plug in. That 96 is pretty big. So I need to put in something that's going to counteract that 96. So 8 did, because this became a negative 88 then. Now, you might have guessed a different number, and that's fine. Find one, any one. Once you find one that works, divide it out. So we multiply and multiply, add. If you don't end up with 0 as your remainder, that's the remainder spot. If you don't end up with 0, then either the number you thought was a 0 isn't 1, or you made a mistake in your division. That has to happen. So what's next? What do I do next? Take this quotient right here and write it as the quadratic that it is. With any luck at all, it'll factor. Does it?
Minus 8 plus 6.
-8 plus 6. If it doesn't, it's a quadratic, so we can use the quadratic formula, right? To find the other zeros. There'll be decimals or whatever, but we can do that. So my factors are x minus 2, that's the one I guessed, and then these guys. So here's 8, here's -6, and here's 2. Again, we don't have any duplicated factors, any multiple zeros. Positive cube, isn't this one just like the other one?
Mm-hmm.
Best case scenario. Alright, you're gonna try the next one on your own, it's the last one in this little set. But before we all jump in to start it, what are our PRRs in this one? Your PRRs, your possible rational roots, are factors of 2, which are just 2 and 1, over factors of 3. Now kids, that means you have 2 and 1, 2 over 1, 1 over 1. But you also have 2/3 and 1/3, plus or minus all of those, positive and negative all of those. All right, so go to it. That's your list. That's where you're gonna get your rational roots. So whatever you're guessing, it's coming from that pile. See if you can find one. Oh, man. One works, doesn't it? I thought this was gonna be a fun problem. Doesn't one work, guys, when you plug in one? Well, that's good news, yeah, that's good news. But I thought we were gonna have some fraction action. So one of my factors is x minus 1. How about 3x squared plus 7x plus 2? Is that factor? I think it does. Doesn't it? 3x plus 1, x plus 2. By the way, some of you were looking at that and thinking, I don't think that factors. Perfect. If you don't think it factors, what are you gonna do with it? Quadratic formula. Your job is to find the roots, guys, find the zeros. The quadratic formula will do that for you.
It's just x minus 4.
So we got 1. We've got negative 1/3. And we've got negative 2. A little bit boring, it's another positive cube. do want you to notice though, are all of those zeros that we found, are they in our list? Yep, they sure are. They sure are. All right. List all of the possible rational roots for this function. Let's make a list. Let's go ahead and make a list of the possible rational roots. So we're going to have factors of 6. So plus or minus 6, 3, 2, and 1. Are those the factors of 6? Over the factors of 2. So all of those over 1. And all of those over 2. Now obviously 6 over 2 is already in our list, but 3 over 2 is not. 2 over 2 is in our list, but 1 over 2 is not. So that would be the actual list of PRRs for this problem. What? Is someone saying something? No? You okay back there? All right, everybody good with that? Okay, let's look at the next question. Because this is an interesting question. So I left this one up here. You don't need to write this down, just kind of look what's going on. I know that if I took, this is like the one you just did a minute ago. If I took this problem and I divided out a 1, I did that, and I know exactly what will happen. This will come out to be a 0, right? Now, here's what I'd like you to do. I know it's not going to work. That's not the point. I want you to divide by 2. I want you to tell me what happens when you divide by 2. So go ahead and do that. Somewhere over to the side, or on another sheet of paper. I want you to take these numbers right here and divide by 2. And then, I want you to divide by -1. Now, I know that's not going to work either, but again, that's not the point. Take the same coefficients and divide by -1. Hopefully I'm dividing right. And then one more. I want you to take the same coefficients and I want you to divide by, there's a reason for this, kids. I want you to divide by -3. Notice that I picked numbers, we already did the problem, so we know this is what it looks like. I picked a number out here, an x value out here. I picked an x value in the middle of all this, and I picked an x value out here. The results of those divisions were very different from each other. And you, having never done this, maybe didn't notice it. But when I divided by this number out here, What do you notice about that bottom row, the quotient and remainder row? What do you notice about those numbers? They're all positive. If you pick any number beyond 1, so like if you put 3 here, they're all going to be positive. 4, they're all going to be positive. 2 is one of the infinitely many upper bounds of the problem. When you, whatever number you're guessing, when you divide it and these turn out all positive, not only have you not found a 0 because you didn't get 0, but you found an upper bound, which tells you do not guess any numbers bigger than that, because 2 is an upper bound, because all of these came out positive. So any number after 2 is not going to work. Similarly, when I put in -3, look at those. What happened to those when I put in -3? They alternated. So when you do your division, you pick a number, you do your division, and they alternate, the quotient remainder row alternates in sign, that tells you that you have found a lower bound. Well, what does that mean? Kids, that can be hugely helpful. Because if you have, remember when we had a problem with factors of 96? That's a lot of numbers. If you try one and they alternate, then don't go any lower than that. If you try one and they're all positive, don't go any higher than that. So you see how you can kind of narrow in if you need to? Look what happened when I picked one that was inside the range. It didn't do either one of those things, right? It's kind of random. So upper bound happens when you divide and get all positives. Lower bound happens when you divide and they alternate. And if something else happens, it's not an upper or a lower bound. All right? Hang on to that tool, because we are going to talk about that next time. Okay? All right. You guys are like Pavlov's dogs. I don't even need to look at the clock. I know what's happening.